All right, today we're going to talk about one of the coolest and most powerful tricks in AI, fine-tuning. We're going to explore how we can take a general, know-it-all AI and turn it into a super focused expert, tailor-made for one specific, really important job. Let's dive in.
So, this is the big question, right? You've got these huge AI models that seem to know a bit about everything, from Shakespeare to quantum physics. But how do you get that same model to do something incredibly specific, like diagnosing a rare disease or analyzing a complex legal document? Well, that's the puzzle we're going to solve today. To really get this, we have to start with the star of the show, the pre-trained model. I like to call it the generalist genius. It's brilliant, but its knowledge is kind of a mile wide and maybe an inch deep. And the scale here is, well, it's just mind-boggling. A pre-trained model is kind of like someone who has read the entire internet. Seriously, it's ingested billions of data points, text, images, you name it, and from that, it's learned the patterns, the grammar, and the context of our world. It's an amazing starting point, this massive foundation of general knowledge. But as amazing as that general knowledge is, it's not always enough. I mean, just because you've read the entire internet doesn't make you a qualified doctor, right? So our generalist genius needs some specialized training for its new career. And this is where things get interesting. This right here is what the experts call the domain gap. A model trained on Wikipedia, yeah, it gets language, but it doesn't speak the super nuanced dialect of legal contracts. And a model trained on a million cat photos knows what shapes and textures look like, but has no idea how to spot pneumonia on an x-ray. We've got to bridge that gap. So why bother with all this? Well, it really comes down to these four key things. We're zeroing in on specific knowledge, we're teaching it a brand new skill, and we're cranking up its performance. But honestly, the biggest win? We get all this without having to build a new model from scratch. That saves a truly massive amount of time, money, and computing power.
Okay, so how do we actually do it? Well, it's not a one-size-fits-all kind of deal. Think of it more like a playbook with different coaching strategies for our AI genius. Each one has its own pros and cons, depending on what you're trying to accomplish.
This table gives us a great bird's eye view of our four main strategies. You can see there's a clear trade-off happening. On one side, you've got something like feature extraction. It's fast and cheap, but not super flexible. On the other end of the spectrum, full fine-tuning gives you all the power, but boy, it's going to cost you in data and computer time. So let's break down what each of these really means. First up, feature extraction. This is the simplest, fastest method. We basically freeze all that general knowledge the model already has, lock it in place, and then just train a tiny new part at the very end to handle our new task. It's like telling our genius, hey, use everything you already know, but just learn this one little final step. The big win here is pure speed and efficiency. This is your go-to when you have a small data set because it lowers the risk of something called overfitting. That's where the model just memorizes your examples instead of actually learning. The downside, it's less flexible and you might not squeeze out every last bit of performance. Now, let's look at the total opposite approach. Full fine-tuning. Here, we unfreeze everything. We let the entire model, every single layer, adjust itself based on our new specialized data. The trick is to use a really low learning rate. Think of it like making tiny, careful adjustments so it doesn't just forget all the valuable stuff it learned in the first place. This is the power move. This is how you get the highest possible accuracy, because the whole model can deeply adapt to the new job. But, and it's a big but, this approach is hungry. It needs more data, more computing power, and it brings a much higher risk of that memorization problem, overfitting. So, what if you want something in between those two extremes? Well, that's where gradual unfreezing comes in. It's a really clever hybrid approach. You start by training just the very last layers. Then you unfreeze a few more and train again, and you keep working your way deeper into the model. It's a very careful, step-by-step adaptation. The real beauty of this method is how stable it is. It helps you avoid something with a great name, catastrophic forgetting. That's when the model gets so focused on the new task that it just erases its original super important knowledge. The only catch is that it's a bit more complex to set up and manage. And finally, we've got a really modern and incredibly efficient method called adapter layers. Here's the idea. Instead of retraining any part of the original model, you keep it completely frozen. You just plug in these tiny new modules called adapters. Only these little new pieces get trained on the new task. The efficiency here is just amazing. You can have one single massive base model and then just swap in different tiny adapters for dozens of different tasks. It is an absolute game changer for anyone doing multitask learning, even if it might not be the top choice for tasks that need a really, really deep adaptation. Okay, that was a lot of theory. Now for the fun part. Let's see where the rubber meets the road. How are these new AI experts actually being used out there in the real world? This is such a classic and powerful example. You start with a model that's an expert at identifying everyday stuff in photos. Cats, dogs, cars. Then you give it a completely new, much smaller dataset of medical x-rays. After a little bit of fine-tuning, boom, it becomes a specialized tool that can help doctors spot the signs of pneumonia with amazing accuracy. And once you start looking for it, you see this technique literally everywhere. It's how a general language model becomes an expert at analyzing product reviews for positive or negative sentiment. It's how speech recognition systems learn to understand unique accents and industry jargon. It even helps self-driving cars learn the specific road signs in a brand new country. The applications are just endless. Of course, it's not always a simple plug-and-play process. Creating these AI experts comes with its own set of challenges, and you've got to know the best practices for getting it right. It's a real balancing act for anyone building these systems. They're always asking themselves these questions. Is my model actually learning, or is it just memorizing the test? Is it accidentally forgetting its crucial general knowledge? Can we even afford the cost of training this thing? And is our data biased? Getting all those little settings just right is a massive part of the challenge. So, where is all of this headed? Well, the process of creating these AI specialists is getting faster, more efficient, and more powerful every single day. And that is opening up some truly incredible possibilities for the future. I love this quote because it really just nails the whole idea. It says, fine-tuning is the art of teaching a well-informed student to become an expert. And that's exactly what it is. This isn't just about programming, it's much more like teaching. We're mentoring this incredibly knowledgeable student until it becomes a world-class expert in the exact field we need it to be. And that leaves us with this final, really important question. As this technology gets easier to use, allowing us to create specialized AI experts for pretty much any problem we can think of, what are the next great challenges we're going to solve? You think about personalized medicine, discovering new materials, even tackling climate change. The potential is just extraordinary. Thanks for tuning in.